Yes, continuation of renewable source of energy. First example already we have discussed solar cooker. What is solar cooker? How to construct? What are the advantages of solar cooker and disadvantages of solar cooker? Second application of solar energy, that is solar water heater. One diagram already have schematic diagram it is given, it is a solar water heater. The solar water heater generally we are using the purpose of getting hot water for taking bath or some other places where we are using the hot water. That benefit we can use it. Soaking cloth or some purpose we can use it. What is solar water heater? A solar water heater has an insulated box painted black inside with a system of copper tubes. That is only it is showing. So insulated, here board it is there. So lot of copper pipes are there. It is arranged in such a way in the form of parallel with each other. It is covered with a glass plate which allows heat to enter inside. So above the all copper pipes are there. Above that one we have to cover with one glass plate which allows sun radiation, heat radiation to enter into inside the glass sheet. But the heat energy will be allowed to pass inside the glass sheet but does not allow heat to escape out. Okay, so whatever the heat energy producing inside, that will not allow to pass out. It will not come out. So that will be doing the work by the glass sheet it is there. Similar property of glass sheet which is covered with box type solar cooker. Same purpose here also it is using. When water flows through the copper tube, it absorbs the heat and becomes heat. Okay, so now this a tank will be there. This one cylinder will be there. It is connected to the overhead tank. From there cold water will become. The cold water will be circulate through this all copper pipes. Then the end will be come out. Here we have to make it another one connection to get it the hot water it is there. So when water flows through cold water, when the cold water flows through the copper tube, it absorbs heat from the sun. After some time it becomes hot. So hot water we will get it, that can be used it is there. Okay. Third important example for solar energy, that is solar cell. Solar cell is a device fabricated with a semiconductor material. Semiconductor material like silicon, germanium, gallium and selenium they are using is a. Solar cell is a device which converts solar energy into electrical energy. So this is a solar cell here. On schematic diagram again I am showing here. So the device having conservation of energy will be there. Sun energy will be radiating. It is reaching on the solar cell. The solar cell is a device which converts solar energy into electrical energy. Then solar cell made from semiconductors like silicon, germanium, gallium, etc. A single solar cell produces a voltage about 0.5 to 1 volt. One small solar cell, solar cell means single, that will be giving 0.5 to 1 volt. Even one small LED also operating is very difficult it is there. And also the one solar cell producing 0.7 watt power also it is there. That much amount of electricity we can generate from one solar cell. The potential or voltage 0.5 to 1 volt and producing the power 0.7 watt electricity. So several solar cell, grouping of solar cell we have to arrange to get it one solar panel to produce more amount of electricity. So solar cell is a very important device for us to convert heat energy into electrical energy it is there. Single solar cell producing very less amount of electricity, so that grouping of or cluster of solar cell together we have to make it in the form of solar panel. Here it is just one example is given. One solar cell connected with one bulb. After getting conversion the heat to electricity, the bulb will be giving illumination, brightness it is getting. It is in on glow. It will be glow because current will be flow through the bulbs. So this is a solar panel. So arranged, many number of solar cell arranged such a way to getting the solar panel. Solar panel is attached with street light lamp also. You might be seen very big city and all, everywhere it is there. The street light connected with one solar panel, one the battery will be there. Okay, storage of charge inside is there. So evening time automatic will be switch on, morning will be switch off. So directly there's without any manual work, that street light and all will be work continuously, it is said. Now advantage and disadvantages of solar cell. Advantages: it uses renewable source of energy, means sun. It produces electricity which does not cause pollution. No pollution here. Where is the pollution? Nowhere it is there. Sun energy means heat energy converted to electrical energy, that's all. It can be used to remote areas where there is no power supply. Still in India, many places are in the remote. Okay, there no electric connection from the electric board. It is unable to possible to give it is there. So there such a type of panel they are using. Now they are using to get electricity is there. Disadvantages: it is uses a special grade of silicon which is expensive. All semiconductor materials are expensive only, because fabrication of semiconductor material from the earth crust is very big process is there. So obtaining such a type of semiconductor material, special type of silicon, it is a more expensive process is there. Since silver is used for connecting the cells together, it is still more expensive. So now we want to prepare one panel, solar panel. So grouping of solar cell, how we have to connect two solar cell together with the help of silver. So that silver also very costly only it is there. So more expensive will be takes place. The current produced from the solar cell, solar panel, it is a DC only. But DC we cannot operate in our home electric fan and all things. So it should be converted into AC. So the conversion of direct current into alternating current also expensive only. So economically it is costly only it is. Next one, energy from the sea, energy from the ocean. So ocean is a renewable source of energy, plenty of water it is there. How we can use that plenty of water in the form of usable way? So in this way, energy from the sea is obtained in three different forms. They are tidal energy, sea wave energy and ocean thermal energy. So first we have to discuss about tidal energy. So generally many people, many students might be visited sea, Samudram. From the seashore you can enjoy how the waves are coming to you and going away from you, like this way there. So the tide will be formed. Sometime we will get it low tide, sometime we will get high tide also. During the full moon day, the moon will be very close to the earth. So attraction between the earth and moon will be more. So 1 to 3 kilometer height, that wave also will be producing high tide. Okay, some kilometer height also it is producing. So now we can generate electricity using by tidal energy it is. That is the first part. The periodic rise or fall of sea level due to gravitational attraction of moon causes tides. Okay, so attraction between earth and moon, automatically the tide will be producing. The tide every time will be increasing the height and decreasing the height. Rise or fall of sea level, it will be takes place here. The dam is constructed at a narrow opening between the land and the sea. One small dam type here constructed it is there. So this is also one schematic diagram, children. So here one small dam constructed at a narrow opening between land and sea. Okay, so the movement of water during the high tide and low tide can be used to rotate the turbines of generator to produce electricity. So here is showing say turbine. So when the water will be go a certain height, so by the time the turbine will be rotate, then while falling time also again rotation will be there. So again electricity will be generating is there. So the turbine should be rotated. So whenever the low tide, the tide will be go up and it will be come down. So both high tide and low tide, the turbine will be rotate to producing usable form of electricity. Second one, sea wave energy. Sea wave, ordinary, not full moon day and all thing. Every time the waves are there, from the sea wave we can produce it. See how the sea wave energy will be, we can use it for getting the electricity. When strong wind blows over the sea, it produces huge waves. It is happening. You might be experienced by sitting seashore. The kinetic energy of moving waves can be used to rotate the turbine of generators to produce electricity. Okay, children. So waves are moving. So kinetic energy producing. So by the time the arrangement kept inside the sea, it is there. So sea waves are moving here, then it will be come back. It is there. It's moving towards the turbine, then it is away from the turbine. So by the time the rotation of the turbine while going towards and away, so by the time so electricity can be generated. But these are all small amount of energy only we can produce it. Third one, OTE, Ocean Thermal Energy. So what is the ocean thermal energy? Generally children, the temperature difference is available in the sea water from the top of the surface and inside. See, one diagram is given. The blue color is the water. This is the top surface of the water of sea. This is just inside. Inside means around 100 meter below from the surface of the water. From sea level 100 meter inside it is. They are having some temperature difference. There is a temperature difference between the warm surface water and the cold water at the bottom of the oceans. The temperature difference will be there. Surface it is a warm will be there, inside cold will be there. How much difference will be getting from top to the cold water? Minimum this difference is about 20 degrees Celsius. The warm surface water is used to boil liquid ammonia and the vapor is used to rotate the turbines of generator to produce electricity. Okay children, here what is here? The top surface, anyhow is here, temperature is more, it is here. Here the arrangement everything is kept, it is here. We are supposed to send liquid ammonia. For vaporization of liquid ammonia, it's enough 20 degrees Celsius. So the liquid ammonia getting vaporization is producing, it is here. That vapor will be rotate the turbine to produce the electricity. Again what happened? That wastewater has to come, the cold water from the bottom, it has to go up and pumped up the cool the vapor back to liquid, it is here. Okay, such a process the cold water is doing. The cold water from the bottom is then pumped up to the cool the vapor back to the liquid. It become cool, again it has to go. It will be continuously going on like this way, it is there. Then small amount of electrical energy can be generated using by ocean thermal energy. Next, another one, geothermal energy. Geothermal energy. It's a rarely, it is available in the world. So, about earth construction, you might be studying in your geography. Earth consists of three important parts. Outermost layer, which is we are calling crust. Innermost layer, that is called core. In between, that is called mantle. Okay. So now here, so this is a surface of the earth. Here it is given diagram. This is a topmost surface. Here, this one. From here you have to go 3000 meter inside. 3000 meter inside. Their mantle is available. Their mantle, what happened? It is there. Somewhat temperature is more. It is up, using that heat or temperature, it will be melt the rocks and other metals which is available. So producing the magma. What is magma? You might be studying in your geography. It is in the molten stage of such a rock and metals are there. That is available inside. So near that hot magma where will be there, nearby one water reservoir, suppose it is possible, that we have to find out where it is available on the earth. So the hot magma as well as the water reservoir together joining means, so automatically the water has to get it heat up with the help of the hot magma. Then steam will be produced. So we have to insert the pipe to get the hot steam to bring out, utilize in the form of generate the electricity. So here the deeper region of the earth's crust is very hot. Topmost layer very less only, but when you are going inside around 300 meter inside, 3 kilometer inside, the earth crust will be hot only, it is there. This heat melt rocks and forms magma. That means end of the crust, starting of the mantle, there it is available is there. The magma moves up and collects below at some places is called hot spot. So hot spot, we have to find out where the more temperature will be there. The underground water in contact with such a hot spot, gets heated into steam at high pressure. By drilling holes into the hot spots, the steam coming out can be used to rotate the turbines of generator to produce electricity. So everything, that a generator, turbine, everything we are keeping in the top of the earth only it is there. So only we have to mine it or drilling it, one hole we have to make it, through the pipe we have to insert is there, where the hot spot we got it. So from there continuous pressurized steam will be come out if that magma and underground waters nearer are there. So that we can bring out to allow to rotate the turbines which is connected to the generator to produce electricity. This is a geothermal energy it is a. See again the diagram, it is shown in the form of little bit bigger in size is there. So you can go through it is a. This is a pipe which is we are inserting to obtaining the pressurized steam. So the temperature we are getting, it is 100 meter itself available. The hot spot you will get it 100 meter from the earth crust also. Some places are available it is there. So 20 to 30 degrees Celsius that time. But hot spot, it's a boiling water, steam will be come out it is there. The last one from renewable sources of energy, that is nuclear energy. Nuclear energy. So lot of energies we have discussed there. So energy released from the nucleus of an atom. In an atom, outermost electrons are there, valence electrons are there. Inside the nucleus contains protons and neutrons. The chemical energy means energy released from the electron, outermost electron from the orbit in an atom. But nuclear energy means the energy has to release from the nucleus of an atom. It has to release from the nucleus, inside the nucleus. From there, the energy has to come. The nuclear energy is the energy released during nuclear reaction. Energy is releasing when? During nuclear reaction. Some reactions we have to make it to release the energy from the nucleus of an atom. During the nuclear reaction, some mass is converted into energy. And so a very large amount of energy is produced during nuclear reactions. Listen children, according to Einstein mass energy relation, E is equal to mc square. The amount of mass, how much we are using for producing the energy, the mass is converted into energy. Okay, so E is equal to mc square given by the Newton it is there. So how the fuel which is we are using, that amount of mass, it will be converted into energy it is. Okay, this during the nuclear reactions. The nuclear reactions are two types. They are nuclear fission and nuclear fusion reaction. First we will going to discuss about nuclear fission reaction. Nuclear fission reaction is a nuclear reaction in which the nucleus of a heavy atom like uranium, plutonium, etc. splits into smaller nuclei with the release of large amount of energy. It is used to make an atom bombs and to produce electricity. To making nuclear fission reaction, the name of the fuel which is we are using, uranium as well as plutonium. It has to split into two smaller nuclei by the time large, enormous, tremendous amount of energy releasing is there. How it has to split? That is a very important. How the uranium nucleus of an atom, plutonium atom, how it has to split. In nuclear power plant, the heat energy produced by controlled nuclear fission reaction, which is called as a chain reaction, is used to produce steam which rotates the turbine of generators to produce electricity. The meaning of this one, you might be hear the word atomic power plant, nuclear power plant. In that power plant, we are generating the electricity using by the concept of nuclear fission reaction. What type of reaction going on? Nuclear fission reaction. Controlled nuclear fission chain reaction is going on. We will discuss now what is a fission reaction, chain reaction and all will be there. We will discuss it now. Okay. So using the nuclear fission reaction, one useful form of energy, that is producing electricity, one more atom bomb also we can generate. One diagram is given, you can see. This is uranium 235 which can be used as a nuclear fuel of nuclear reactor. Okay, atomic power plant we are using as a nuclear fuel, that is called uranium 235. So now the uranium 235 has to split. How it has to split? One slow moving neutron, it has to come. Slow moving neutron means less energy neutron. Less energy neutron has to incident on this nucleus of an atom, uranium nucleus of an atom. It has to go inside, then it will take some few seconds to split into two equal medium size nuclei. Along that, three neutron again. These three neutron, fast moving neutron. These three neutrons are fast moving neutron. Along that, tremendous amount of energy is releasing. Tremendous amount of energy is releasing. A slow moving neutron bombarding with uranium nucleus of an atom split into two medium equal size weight of the nuclei and three neutron and tremendous amount of energy. So the three neutrons is we can call as a fast moving neutron. Again this fast moving neutron we have to slow down to bombarding with another uranium nucleus of an atom, it is there. Okay, now you see one uranium giving three neutrons. Okay, so that now here again same diagram in the form of given chain reaction. The neutron reacting or bombarding with uranium nucleus, two nucleus, another nucleus we are getting, that is called barium and krypton. So atomic number 92 of krypton, atomic number barium 141. Along that three neutrons are there. These three neutrons are little bit high energy, we can call fast moving neutron. This fast moving neutron again we have to slow down. So some of the moderator they are using, according that one it is getting slowed down. So this slow moving neutron again bombarding with 3 uranium, then again 9 neutron will come, again to be reacting with 9 uranium, then 27, that is 81, one arithmetic series it will becomes. In a minute 10 to the power of 10 reaction will be takes place. It's a continuous chain reaction. Once install these neutrons, that will be going on. So by the time tremendous amount of energy is producing. But in nuclear power plant we are using controlled nuclear fission chain reaction we are using, it is there. Okay. Now one video I am showing to you children to how
Friends,
the nuclear reactor
let's
is working.
take a moment to understand the working of a nuclear reactor. Nuclear reactors are the modern day device